Hello all, welcome to my channel. I'm back with another video. In this video, we will be looking at the architecture of a feature platform. So let's get started. First thing first, why do we need a feature platform at all? So the feature platform is a platform which helps us in providing the inputs to an ML model, and that's the whole purpose of a feature platform. And the reason we need it is that the features that we fed into the ML model is what makes the model work in a certain way. If we and also these features make the model behave in a certain way because these models will be trained on these features itself. And why do we call it a feature? And the reason we need a feature platform is the data engineering part of this feature platform is the part where we do a lot of transformation. So we have data which is not in a canonical sense is not a feature available as of now. Means as of now in a sense in a certain stage. So this feature platforms helps us in making the data which is available to us be able to be called a feature. So this transformation from raw data into a feature is done by this feature platform. This feature platform does involve certain data engineering aspect as well, like some transformations which we do is part of data engineering, but we call it a feature platform because it is specifically designed only for feature generation rather than doing analysis on top of it. Hence the feature platform is needed. So what are the feature platform components that are there? So the component wise, if we say, so a feature platform will have in general uh, it will have 5 or 6 different components, like it will have feature design, which will have feature catalog, which will have feature computation engine, feature store, feature governance, and feature monitoring. So these will be the 5 different components. The major component as a platform, uh, which is very much important and which should be there. So these are the ones which are there, but feature store and the feature computation engine, like these three, feature catalog, computation engine, and feature store, will be something which is of utmost importance, and we will see these things in detail as well. So first thing, what is a feature design? So feature design is a process where we will be selecting certain data sets, and those data sets we will be deciding on the what is the feature that we want to get out of it. So this feature design is nothing but crafting features from the raw data that can be used by machine learning models, either for ML training or for ML inferencing. So this will require different stakeholders to get engaged, because this will need a feature design or a feature creation service will need to have, let's say, integration with the data hub or the data catalog that will be in the company, so that everyone knows what data I am working with. Then we also need a mechanism that the features needs to be interoperable, granular, reusable across systems. So, for example, let's say 2 models are there and they consume, let's say both of them consume the same features, or a subset of features of them are same, then we should not be computing that feature twice in our platform. Our platform should only compute feature once. So that becomes a feature design part. Then we have feature catalog. So feature catalog, again, it is part of feature designs extension, I can say. So when we have already created a feature, we need to register it in a catalog so that others can search it. For example, if let's say team A has already built a feature, let's say in a car transaction system, if we say that a feature is a boundary box, or let's say 5 meter mile B box of a geographic location of a POS is let's say one feature that we gets fed into multiple models. So that feature, if we have already calculated, because that is not going to change across model to model, because all the card transactions will have a POS devices geographic location in lat and long format. And then if we create a 5 mile radius of that and create a bounding box, and then we create an area of interest for that, that is one feature which will remain consistent across all the models that will consume. Hence, we only need to create that feature once, register in the catalog, and if some other model needs it, they will simply pull it from the catalog. That's what this catalog will do. It will store all the features that has been defined. It will also store the way it has been defined so that it can be reproduced in case if we lose it, or let's say it can find out the overlaps between two different features that is available, and that can be created as one feature, and then extension of that can be created so that the computation of the feature calculation is not happening twice. Then we have the feature computation engine, like the engine which will calculate the features. For example, it can be Spark, it can be Dask, Dart, Polars, or whatever it can be. Flink can also be an feature computation engine. So this engine needs to be available because we will be creating features for both batch and real-time systems. We need something which is scalable, which can be distributed. So examples of this feature computation engine can be Spark, DBT, Flink, or SQL-based processing engines that are there that can also be used as a uh, feature engine, feature computation engine. Then we have feature store. So this feature catalog just stores the catalog, metadata and everything, but where that the calculated features needs to be stored, that needs to be scalable, that needs to be accessible very fast. So that's why this feature store is important. And it's a specialized data management system which stores the features and renders it in real time, for the online cases and for ML model in training, in case of we are doing a batch training, or we are doing a batch inferencing as well. So in that mode, we will be needing an offline. So there are two types of feature store. One is online, one is offline. Online is a feature store which is real time, which stores the features calculated on the fly, and offline features are which have been calculated and stored and can be used not can be used as in batch mode, or not in a real time scenario. So that's where this online and offline features are there. So in a sense, we can say that online features are which does serve the live model inferencing part, and the offline feature store serves the batch mode or the training part. So that's where these features are stored, means like feature store is needed. Then we need feature governance. Feature governance is like, I mean, like all the processes and policies that needs to control the features quality, security, compliance and accountability, those kind of things. For example, if we are storing feature in some form which exposes PII data, then we should have a control mechanism. Or let's say if we have some other information which should not be disclosed or which should not go out of the corporate network, so those kind of compliance and everything can be implemented, or this version control, validation, everything is implemented using this feature governance component. Then we have feature monitoring. This is to monitor that the features that we are generating are actually the ones which are needed, and the models are continuously monitoring that to see the features, whether the feature needs to be tuned or the model needs to be retrained based on certain aspects of that. And hence this feature monitoring is very much important, and the feature platform should provide users with the ability to continuously monitor the features quality, its usage, its staleness, its overlap, and then provide recommendation and ranking for those features. So that's how this feature monitoring is very much important. Um, so we have already discussed why we need a feature store is that we need a feature store because, for example, in this case, if you see enterprise data is there, and data engineer, what it will do, it will deduplicate the data, then data scientist will model that, create a model out of it, and do the training, and then do model serving and everything. So there are different hops that is happening, but if we have a feature store, so the enterprise data and the model serving is one single place where everyone can collaborate. Like data engineer can write the transformation, data scientist can provide the logic which makes the raw data into a feature. An ML engineer can continuously monitor and deploy those features to be available on the model serving part. So that's how this thing will work if we use a feature store rather than using a broken model where one team does one part, other team does the other part, and then we have to do a lot of back and forth to make the features work, and there will be out of sync as well. So if we use a feature store, it will become one single collaborative platform that allows us to uh, see the data and the output of the model in end to end. And that's why this feature store is very much important. If we say in another terms, so there are, as I mentioned in earlier, there are two different layers to it, like one is online, one other is offline. So this is how in general structure of a feature store will look like, that we will have a real-time data source, then we will have a batch data source. So there are different mechanisms, like real-time data can push the data to batch, for batch platforms calculation, offline feature calculation and model running pipeline. Or it may also happen that the batch pipeline, whatever they calculate the features as an offline, they push that features to the online store so that it can be rendered and it can be used for a real-time model in production that needs to be continuously inferred. So that is an structure that generally is followed. And a feature store will have different layers like data infrastructure layer, orchestration layer, metadata layer, and serving layer. So this is what, for example, data infrastructure layer will be something which computes the features, and because we have two different modes, for example, we can have real-time data transformation, and then we will have another set which is batch transformation. So batch transformation is called offline, the real transformation is called online feature store, and the infrastructure layer that we use depends on what kind of workload is we are processing. If we are processing real-time data, we need an engine which can process stream data, which is in this case can be Flink or a Spark structured streaming. And in case of batch, we can use any tool which is available at our disposal. It can be Spark, it can be a Snowflake as well, it can be ClickHouse or other systems as well that can provide features. One thing that we notice, we want both of these to be in sync. For example, whatever computation we do in the batch mode, same or similar computations would happen in the real time mode and vice versa. And hence, this the logic of these two should be made in such a way that we are not deviating from the business model. Although we might have different layers, different what you call different code implementation, but the business logic remains should remain same between these two infrastructures. Then we have feature store. This is the engine part. Then we have feature store part as well, that where we store these things. We can store it in Snowflake, ClickHouse. We can store in not Spark per se. We can store it in a Lakehouse system and then consume it from Spark or Presto. That can be done. And online feature stores, we have Redis, Dragonfly, DynamoDB, which have very low latency serving capability. We can think that of as an what you call feature stores layer. So this is one data infrastructure layer that we need. So raw data is coming from Kafka, and in the batch mode, or the raw data is coming from DBs that we can have, or the file system that we can have. So Spark will calculate the batch, and then it can do a dual write. It can update the offline store as well as the real-time store, and same goes with streaming. It can do a dual write as well in async mode. This mode, sorry, Spark streaming, or the streaming calculation to streaming online store will be synchronous, while this one will be asynchronous so that it can be offloaded to a later time. So this is one data infrastructure layer that we will have. And then there is a use case of syncing between online and offline. So this is what I was talking, like there are different approaches. One is streaming first. That means that the online computed features will be written to both Redis and Snowflake simultaneously. So the batch part will aggregate later on, but the real-time features will be written both places. Then we have batch sync mode, where we will periodically export the recent values from Snowflake or the batch systems to Redis. Then we have dual write, where we are writing both the application logic is written simultaneously to both Redis and a raw logs or a Snowflake system. And then we have another approach where we do a CDC approach, where what we do is the real-time systems as it is, it keeps on happening from the real-time part. But the batch part, what we do is whenever we see a change, we sync those changes to both the stores, like it can be to Snowflake or to the Redis part as well. So both online and offline stores are updated based on the CDC that or the change that we have detected in the system. So this is one layer, which is the of a feature store, which is the data infrastructure layer, like computation and the logic. Then we have the serving layer. So serving layer is a feature what you call a layer, which says that okay, for batch how we will get the data, and for streaming how we will get the data. So for example, here if we say we have a serving layer on top of let's say we can have a feature serving API, which can be let's say web server, which is exposing this data in Redis as well as in S3. And when we are doing in a real-time mode, we make an inquiry inference means we want features to be pulled. So we have an SDK which knows that okay, I want to fetch data from. So it will connect to this server, and this service will fetch the data from Redis and supply it. In case of batch, it will talk to the service and fetch the data from offline feature store and then serve it for model training and other purposes. So there are, for each of these systems will require two different mechanism. Like we can't we might have feature training sorry, the training features or the batch features may not be being served by an API layer. It might be using some other layer, like instead of a web server it might be doing some gRPC or direct file copy to this environment, because this will be a huge data that we want to fetch. In case of real time, because this will be a point lookup, we can serve it via the web server as well. The other thing that is coming in nowadays is that we can have a unified feature service layer. So at the training time, it can decide where to pull it from. For example, we can have a system which talks to both Snowflake and Redis, and at the inference time, it decides that okay, which layer I want to pull it up. So we will have two SDKs. One is, so we can have a flag saying that okay, whenever the inference is made call, we can say batch mode true or false, and based on that, it will fetch the data from that. The abstractions will be like this: get online features and get historical features, something like that. So this is another layer. And then we have the orchestration layer. So this layer is what orchestrates the whole part. Like for example, we are invoking stream as well as batch. So to orchestrate that, we can have a layer on top of this. Let's say it can be a airflow system, or it can be a orchestra system, which does the orchestration of different jobs that we have, and that then the feature is getting generated based on a certain schedule. So this is, and then another part is, as you mentioned, registry and metadata. So registry is very much important because features needs to be discovered. And let's say if we are for online stores, for example, Redis or something, or let's say offline stores as well, we can store this in a catalog system like Glue or Data Hub, so that features are registered in there, and then can be discovered and consumed from the what you call feature store. So this metadata will only point that okay, this feature is present in this feature store, and then you how you fetch it. So that kind of information it can be there. Then we have governance, like we want to see the lineage. So the governance layer should have this lineage. It should have access control and monitoring inbuilt. So this will be something that we will have to see if the feature platform does have these things or not. And then we have some deployment consideration, that we can deploy it on cloud, we can deploy it on hybrid environments, we can do CI/CD using GitOps or Argo, and integration with Airflow and Dexter. So this will be an basic structure of a feature platform that we want to build. This is part one. In part two, I will cover the remaining a few other things related to this feature platform. So stay tuned for the next video, and till the time, have a nice day.